Today on the bench a Kenwood TH-D7 which will not charge its battery. So let's see what's going on here. Welcome to TRX Bench. Okay, these radios get charged here over this DC port, and Kenwood was so kind to write here on this little clips here that it is DC in 13.8 volt, and they give us the polarity here, which is very handy. And well, putting the DC connector here into the plug, we do not have any battery charge. And yeah, this is a replacement battery, so it's a power battery. So for any reason it will not charge, and the battery itself seems to be completely empty, so the radio doesn't work with the battery. So let's see what's happening if we put the DC connector to it. Okay, and because we have here the information that we can put 13.8 volt to the radio, I put my power supply to 13 volt, and of course I can switch it on. And yeah, we see there is no current drawn so far. And okay, let's see if we now can switch it on, and no, we can't. So that is definitely not a very good sign. So first of all, let's check if here our charging wire is working, and then yeah, let's see what it's going on with battery and etc, etc. Okay, and therefore our first check will be if there is everything okay here with our wire. And as we can see, so we have our 13 volt, which is dialed in to our power supply, so this is fine, no problem. And the next check, of course, will be here our battery. And let me place here, oops, I do not see nothing, so it looks like that the battery is completely dead. So if we see this here, it is not only a volt, so 700 millivolt. So that means the battery is definitely completely dead, and that of course is the reason why we are not able to switch on the radio. So maybe that this battery has never been charged, because I have been told that this replacement battery is new, and so most likely it has never been charged, or maybe that this battery for any reason destroyed our charging circuit in the radio. So that is what we need to find out. And first of all, well, let's simply check if the radio works if we supply here our radio directly with 7.2 volt, and if we supply the voltage directly here to our contacts here, then if the radio is working just fine, the radio should fire up, and then we have a first overview. And if you're doing something like this, really make sure that you don't mix up here the polarity, because otherwise you would kill the radio. So always double check if you connect it directly here to these ports. Okay, so let's try. And that is looking good, so no problem whatsoever. So the radio is firing up, so everything is fine, and yeah, we can obviously operate the radio, so no problem. And well, so that obviously means that here is definitely something wrong with our charging portion of the circuit, and yeah, maybe the best first step is to see what our schematic is telling us. Okay, and here is our charging circuit. So let me zoom in a little bit that we can see it better. So very often, if there is no charging, there is a little fuse which is responsible that something is going wrong, and of course you see that we have a little fuse down here, but this time it cannot be the problem, because you may see we have directly connected here our battery ports to the circuit, and we have seen that the radio was firing up. So as you can see, it will go here over this fuse, and if this fuse would have been blown for any reason, then the radio wouldn't fire up. And without the charging wire connected to the radio, so this is here our DC terminal, you see, so without a cable inside, or a plug here inside, we would get our minus, right, for battery operation here over our DC contact, and then it goes to ground. All right, so we always need a working DC port, or in particular this little switch here, that our battery operation is given. So if that would be broken, our radio wouldn't fire up with the battery, right? And therefore we can assume that this portion here is working, because otherwise no function. All right. Then if we have it in charging mode, we would definitely have two things. First of all, the radio would get fired or supplied by our DC wire. So you can see here our plus line, and then it goes here over our fuse, and the radio should fire up, and our contact here is open, but in DC operation or power supply operation, let me call it that way, minus is directly connected here to our plug, and the radio should work with only our DC connector. But we have seen that we are not able to fire the radio up, and our operation, our charging operation doesn't work. So therefore, if we follow our current path, you see simply that here our little transistor here is our recharging circuit, And if you follow along here, our plus is over this diode directly connected to the plus of our battery, and our minus, so this is here disconnected, so that doesn't work. But what you can see here, that we have here a constant current configuration, which means if we follow along here our plus line, it goes to the battery, and the charging current will go here over our battery and comes here back over this charging transistor, and then is here going to ground. And that is the charging configuration. So we need this transistor working, and of course we need here our positive voltage also coming here from our plus line, all right, over this dual pack of diodes, and then our battery get charged. But beside that fact, without any battery charging, right, the radio should fire up, because once again we have here directly our plus connected to the circuit, and our minus is directly connected to ground. So the radio should work, okay? So the question is, if we have a symptom like we see it here, is already something wrong here with our plus pass? Is here something wrong, or does the radio get no ground with our charging power supply connected here to our radio? So suspect may be here our D3 or maybe L1. We need to see what kind of component that is, but it looks like that maybe something is already here on this pass, because otherwise it should fire up the radio. Because have a look, if we connect here directly our contacts, is this the same signal parse, right? So there is no difference, and the minus here is connected via our DC plug to ground, and if a plug is in, then we have ground, and it is beside this portion here, it is the same signal or DC pass. So this D3 is highly suspected for a first guess. So let's start to see what's really going on here on this portion of our circuit. Let's crack the radio open and let's see what we can find. Okay, here we have our radio open, and this here is our charging port, and this here is our charging transistor. But as we said before, we are more interested in our D3, because that is definitely the supply line for the radio itself, and we have seen that we do not have any function if we supply it directly, and our D3 is here under this shield. So that, let me see if we can see it here a little bit. By the way, this here is a little fuse we have seen, and we know already that this fuse must be working, because otherwise the radio wouldn't work. Alright, and yeah, barely here under our shield, yeah, we see at least here the both contacts according to our PCB plan. So that here must be our D3, and of course all the power has to go through this diode, and due to that it is clear that it is not a little tiny diode, it is more or less a power diode, and therefore, yeah, that makes sense. And if we check here some points, so maybe first of all, this here is a little diode, which this is D4, which is in our charging pass, and we can check this diode, and we have continuity or not continuity. It is in diode test, and it is showing that the diode is okay, and now in reverse it is open, and that is of course right. This here is our charging transistor, it is a NPN, and this here is a base, and so this is a collector, and it is showing 0.6 volt or voltage drop, and this is the emitter of this transistor here, and again it is 0.6 voltage drop, which is fine. So now reverse direction is open, and let's check here between what do we have on this pass. Don't know, but this is emitter collector. Let's double check what we have here. So this should not be there, but I have to take into consideration that maybe it is due to the fact it is in circuit, so that is something we need to investigate a little more. Here let's check our fuse, and it is full continuity, so everything is fine. And when I go down here to our power diode, so this is anode, and down there, so that should be cathode, and this diode is open, so that is what I have expected. So let's check reverse, but oops, that was a short I was here doing. Oh no, it is obviously not short. It looks good. That is funny, because it is different to what I have seen here in on our board layout. According our board layout, this here should be the anode side, and this here should be the cathode. But if I go down here testing, now we have a voltage drop of 0.6, which is a little bit funny, because normally it should be in this way. So okay, the problem is we cannot get here any closer to the circuit. That means we have to take off our shielding to have here a better access. And saying that, yeah, you already see it is soldered here down to the board. So of course we have to undo this solder points, and additional to that we have here these screws, where it is also connected or fixed to the PCB, But yeah, as I said, that is not the whole story. We really need to undo this solder joints to get closer to our shielding, or otherwise, or not closer to get our shielding off. So that is what I wanted to say. Yeah, let's do that. Let me take off here the shielding. I mean, we need to get access in any case, so we have to do it anyways. Okay, so shielding is off, but my board view I had was misleading, as it is a bad copy. So this here is not our D3. So our D3 is on the foil side, so we have to take off our complete RF board here. So you see here our amplifier and so on. And so yeah, that is a complete RF board. And to check finally what's going on with our D3, what we are interested in, we have to lift it up, and then yeah, let's see what we find underneath. Okay, and this is now the foil side once again. So this is our component side. All right, we have here our DC connector, and we flip it over, and now we have here the foil side, and that means this here are our battery contacts. Okay, and here this are the pins from our DC connector. This is here a suspect coil L1, and now we are really here at our D4. So this is here obviously our D4. I hope. We have to double check. Or is it a capacitor? We double check. But anyways, let's check here first of all if we have continuity here through our L1. And just to remember where we are, so this is our L1, which we found already, and that is our D3. And we want to check if we have continuity from our pin here in our DC plug, and then over this L1 to our D3, so that we have continuity on this way. So that will be our first test. Okay, so now I'm sure enough, I've double checked the PCB layout, and so that means here of course we oops, sorry, you can't see it. Here is our input pin, and I just want to make sure that here right from our input pin we have continuity to again around the camera. It's always funny. So I just want to see if we, yeah, here we have continuity, so that is just fine. So that means now our DC parse is coming here from our center pin, which is here, will pass this filter choke here, and then here goes over this diode, which is our D3, and then we are again in the same portion where we get the battery voltage input. So that means we can test here from our middle pin right to the little filter here, and we have continuity. And now we go over the filter and go ahead and here it is. It is already our filter, which is gone. And that was what I've seen as suspect. And here our diode. So let's check the diode. So the diode looks good. Reverse direction. And reverse is open. Very good. So that looks like that our diode is still okay, but definitely here our filter is gone. So we have to take it out, and we have of course to replace it, and then maybe that was all what's wrong, so that we are able to have then back a working radio. And best here is using our hot tweezers to get it out here. So let's see, and here we are. It is already out. And now let's see if we find a replacement. Okay, so I have not completely the right component, but it should work. So these both filters are very similar. So let me put this filter into the circuit, and let's see what's going on then. Okay, so our new component is in. And it is already cleaned. Everything looks pretty nice. Yeah, let's bring now the PCB back in the housing, in the chassis, and then let's see if it works. Okay, and ready for testing. So we do not need our shielding for our test. So I've already here connected our DC plug, and I have not connected our battery. So the first test we want to do is if the radio will fire up with only here our DC supply, because as we have seen it in our schematic, that should be possible. So we do not need our battery to operate the radio. So therefore that will be the first test, and therefore I have connected it to power supply. I'm not giving directly 13.8 volt to the circuit. I think 8 volt should be fine, and my current limit is at 570 millivolt, enough to destroy the radio. But anyways, let's see if it works. So we go back here to the radio, and I will switch on my power supply, and power supply is on. Alright, and now let's see if we can fire up here our radio. And good enough. Yes, it is back. It is back working. But what we don't know by now is if we can charge our battery. So we know this function is given, and now we need to know if it works together with our battery. As you see, radio is switched off, but we have connected here our DC plug for charging purposes. And the question is, how can we test if the battery pack get charged? So that is very easy, because as I've explained in the beginning, our recharging circuit has a constant current source, and that is our Q6, which we have down here. So we have of course seen it, and this constant current is between 60 and 70 milliamps, and that is the charging current. So if the radio is switched off and we see on our power supply our charging current, and that is what we see 62 milliamps, and that is telling us that the battery is getting charged. So yeah, it takes 16 hours until the battery is full. So now we know our battery is really empty, and so it will really take a while. One tip, and that is what also is always mentioned in the user manuals. Before you put your wall plug into your AC outlet for charging, it is very important that you have first your plug here in the radio, and then after that put your AC plug into the AC wall outlet. Don't do it the other way around. So don't put first your AC plug into the AC wall outlet and then plug it here into the radio, because that is the situation where you easily can cause shorts here with, you know, your plug, because you are wiggling a little bit, and that is very often the reason why we have problems. So always first put here the plug in and then the AC plug. Yeah, that's it. And radio is running, so my last job is only putting here my shielding back, but we can say radio is fixed, everything is working just fine, and therefore we are really at the end of the video. Hope you enjoyed it a little bit, and if, please give me a big thumb up, and catch you next time. Bye!